Hello, my name is Alex Harepko. I work for Pulsa here in Rochester, New York. And today we're going to talk about performing a full prime of this Model 880 pump with flat diaphragm. Now, why do we need to prime? Well, we want to establish the proper hydraulic action between the piston and the diaphragm. We want to also remove all the air from the hydraulic system. Now, the tools that I'm going to use for this task are, first of all, a 1 liter container of Pulsa Pulsa Lube 1HG-QT, so it's 1 quart of the premium oil. I'm going to use a nut driver here to remove the screws from the cover. We're going to need a 5/8 inch combination wrench to adjust the hydraulic bypass valve. We're going to use a 1/2 inch combination wrench to remove the air bleed valve as necessary. I also have a 7/16 wrench to remove the nuts holding the coupling guard in place. I'm also going to be using a pair of fine needle nose pliers, a adjustable wrench, my marking pen, and lastly a short piece of polyflow tubing, 1/4 inch in diameter, that I'm going to use for diverting the flow from the hydraulic bypass vent into the sump of the pump. Okay, I'd like to identify the components, the major components of this pump. Obviously, this is the motor. Okay. This is the pump itself. At the back end of the pump, this is the stroke adjustment, and it includes a little stroke lock. So if you're going to make any adjustments, you need to push the lock forward, and that will release it and allow you to make this adjustment. This is the coupling guard, and underneath it is the connector that's used, the coupling between the motor and the pump. This is the gearbox of the pump. Out front here, this is the reagent head, where the chemicals come in contact with the pump. Okay. Behind the reagent head is the pump head. So I'd like to now describe the major components of the pump head. This is the pump head here. At the top of the pump head is the automatic air bleed valve. Directly behind the air bleed valve is the hydraulic bypass adjustment screw. And then beneath the pump head, at the bottom here, is the automatic makeup valve. This is what adds hydraulic oil to the system, and it draws oil from the chamber, the front chamber of the pump itself. All right, the first thing I'm going to do is I'm going to adjust the stroke to 100%. But before I do that, I want to make note of what the current stroke setting is so that we can return this pump back to its original stroke setting. To make the adjustment, I need to unlock the stroke setting. So I'm going to reach around here and pull the lock forward like that, and now I can adjust this to 100%. And here we go. And once I get to 100%, I'll release the lock, and I'll just rotate it a little bit to make sure that the lock is re-engaged. The next thing I'm going to do is I'm going to remove the cover. So for the purposes of this demonstration, we've removed most of the screws already. But it's a 5/16 nut driver that I use to remove the screw, and I'm going to just quickly unscrew this. Put that aside. I'm going to open the cover now. Pump body here includes 2 chambers. Okay. There's the rear chamber that has the worm gear and drive gear and cam, and is connected to the piston via this pin. The front chamber is the chamber that supports the piston cylinder and piston. What I'm going to do now is I'm going to add oil to the rear chamber first, and I want to get the oil just so that it's covering this crosshead right here. So where's my oil? There's my oil. Give me one moment to unscrew it. So I'm going to pour that oil inside here. Now please note that there's a divider here between the two chambers, so oil doesn't flow between the two chambers. And that looks pretty good. I've got it covering that the crosshead right now. I'm going to add just a little bit more to, that's good. All right, now the remaining oil I'm going to pour into the front portion of the pump body. And the goal here is that I want the piston to be covered. So when the piston is moving back and forth, I don't want the piston to be scavenging any air. So that looks pretty good. I got a good covering of the piston right now. Right. My next step is that I'm going to remove the hydraulic bypass adjustment screw. And I want to make sure that I return this adjustment back to its original position. So what I'm going to do is I'm going to put a mark on it, and then as I unscrew it, I'm going to count the revolutions. Okay. This is where I'm going to use that 5/8 inch combination wrench. So 1, 2, 3, 4, 5, 6, and I'm out. Okay, so now I can take the adjustment screw and just set it aside. And if I look down inside here, there's a spring. I'm going to take my needleless pliers and I'm going to press it into the spring and put a little pressure to grab it. And I've now removed the spring. We'll set this aside. And down deep inside here is the seat valve assembly. Yes. And this is what the assembly looks like. I'll put this on here. You can see the plastic disc, which is the seating surface, okay, and then the assembly that supports it. I'll set that aside. I've removed the seat assembly and spring from the hydraulic bypass, and now I'm going to insert the hydraulic bypass adjustment screw back into the port and just give it a couple turns here. All right. Now I'm going to take that piece of polyflow tubing, 1/4 inch polyflow tubing, and I'm going to insert that into where the vent is. I'm going to take my pencil here and just point to where the vent port is. The vent port of the hydraulic bypass is located right here. So I'm going to take my tubing now and just press it in there nice and tight. Went in there perfect. So I've got a good seal, and now I'm going to bend the tubing down so that I'm going to push oil back into this reservoir. So now I'm going to just put a little pressure on this to hold it in place and prevent it from squirting any oil out. I'm now ready to run the pump. So my colleague here will start the motor. And I can see that the tube is filled with oil very quickly. And what I'm looking for is I'm looking for air bubbles to come out at the other end of the tube. Looks pretty good. I don't see any air bubbles at all. It seems to have filled that tube immediately for us. All right, we've begun the process of filling the reagent, not the reagent head, the pump head with oil. And what's happened is that the oil level inside this chamber has dropped a little bit. What I want to do is I want to raise that oil level so that I'm covering this piston as it enters and exits the cylinder. So I'm going to quick grab the oil here. And that's probably enough right there. Maybe a little more, huh? All right. Great. Now, what we're also going to note too is we want to observe the action of the air bleed valve. And I think when we run the pump, we should be able to observe air being pumped back in to the pump via this tube that goes down around the bottom of the chamber here. So my colleague will start the pump. And there's some bubbles right there. So that's telling me that the air bleed valve is working. Okay. Air is being bled out of the valve here, back through the tube and into the chamber. We now want to remove the coupling guard so that we can manually rotate the motor shaft. This takes a 7/16 wrench, okay, and you can see that I've already loosened it. So I'll now remove it with my hand. And for the purposes of this video, I've already taken the back screw out on this side of the coupling as well. I'll set this aside. And now what I want to do is I want to rotate this coupling manually, and I want to make sure that the pump piston is fully retracted. So I'll start rotating it here. All right, the next step is I want to remove the hydraulic bypass valve adjustment screw, and I only had it in there a couple turns, so I've taken the screw out now. I'm just going to set it aside, and now I'm going to put the seat valve in. I'm going to use my needle nose pliers. Let me just bring the seat valve in a little closer to show everyone what it looks like. I'm going to reposition it on my pliers here so I can get it in straight. All right. So I've dropped that in there. And looks very good. I've got it in the right position. The next thing I'm going to do is I'm going to insert the spring. And I should be able to just drop that in position. Perfect. And lastly, I'm going to take the adjustment screw and return it to the port. So now I'm not going to completely tighten this down to the settings. I'm just going to give it a couple good turns here to keep the parts in place. All right. Now what I want to do is I want to remove the air bleed valve. Okay. Now to remove the air bleed valve, I first of all have to release this little lock. Okay. There it goes. So I've removed the tube from the air bleed valve. I'm going to just set it there, and I'm going to use my 1/2-inch wrench, my 1/2-inch combination wrench, to remove the air bleed valve. So I've got the air bleed valve, and make note that there is this copper crush washer which provides the seal between the air bleed valve and the port. So I'm just going to make sure I don't lose that baby. All right, you can see the washer. Let me set that aside. Now what I'm going to do is I'm going to move the piston forward by rotating the motor coupling, and I want to fill this air bleed valve port to the top with oil. Because what has happened is that the oil is in the reagent head, is in the pump head, but it's only at this level here. The same level as inside the front chamber. What I want to do is I want to bring that oil level up into this port here to get all the air out of the system. What we've done here is we've added some piping to simulate the actual process. We need to be able to create some back pressure on the check valves in order to get that diaphragm to fully work efficiently. what we've done is we've connected up some clear tubing here to the suction side. We've got a gauge here to indicate the back pressure on the system. I've got a simple gate valve that I'm using for adjusting the back pressure. And then we're just recirculating back into this bucket here of water. So as you can see, I'm getting flow out of the discharge side of the pump. And what I've done is I've closed down this valve. So now on every stroke, I'm getting approximately 20 psi back pressure on the system. Pump looks like it's pumping really well right now. So the next step that we're going to do is we're going to finally adjust the hydraulic bypass. Okay, we're in the final adjustment of this pump. If you recall, we removed the hydraulic bypass adjustment screw, okay, and we counted the number of turns, and it was 6 turns from where it was set. So I'm going to now remove the screw to establish my starting point. Okay, I have it in my hands. I'm going to put it back in, and now I'm going to count those 6 turns. So 1, 2, 3, 4, 5, and 6. And it's just getting a little tight there, so I'm just going to give it a little tightness with a wrench here. Great. Very good. I've completed the adjustment of the hydraulic bypass screw, and now what I'm going to do is remove my tube here that we used to perform the test or the procedure. And the next thing I'm going to do is I'm going to replace the cover. Okay, got that cover almost on. I'm just going to tighten down the last screw. Perfect. The next thing I'm going to do is I'm going to replace the coupling guard. All right, we've got this pump all back together. We're flowing water through this, and I'm pointing here to the air bleed valve, and you can see that little shot of oil bumping, and that indicates that the air bleed valve is working properly. Okay, to conclude this procedure, we want to make sure that we put the stroke adjustment back to the original setting that the customer had. And I believe it was set to around 80. We had set it to 100 for our procedure. So I'm going to push the lock forward to unlock it and reach in here and rotate this till I get to the 80. Okay, there's 80 right now. I'll release the lock, and I'm just going to jiggle it a little bit to make sure that it's engaged. Perfect.